Welcome back to Zooming into Math. Today's learning target, I can use what I know about fractions to measure angles. So very quickly today, the three fractions or benchmark fractions that we're going to refer to or make reference to are going to be 1/2, 1/4, and 1/8. So very briefly, before we get into today's learning target, let's recap what we already know about angles. So when we talked about angles, we talked about a right angle measuring at exactly 90 degrees. We talked about an acute angle measuring at less than 90 degrees. We also talked about an obtuse angle that measures greater than 90 degrees. And then we also talked about that straight angle measuring at 180 degrees. We're going to now use what we know about angles to figure out how to measure the unit of a circle. I can use what I know about fractions to measure angles. So one of the things that we'll notice that's different within this week's learning target is when we actually talk about measuring those specific angles. So what we're going to take a minute doing today is just taking a moment to look at a circle and talk about this particular circle. So within a circle, when we're talking about measuring angles, we first have to go with what we know. We know that a circle is 360 degrees. So we're talking about the full range, that rotation of that circle is 360 degrees. So now if we're talking about what we know about fractions to measure angles, I can take that same circle that measures 360 degrees and I can divide or partition this circle into halves. So in doing so, what I'm actually doing is taking that 360 degrees and I'm dividing it into two halves. So each half of that circle would be 180 degrees. So taking a look again, this fraction would be 1/2. So using what we already know about fractions, and we talked about our second benchmark fraction being fourths, I would then take my circle and partition into fourths. So in partitioning this circle into fourths, what I'm actually saying is I'm now going to take my 360 degrees of this circle and now I'm going to divide it into 4 equal parts. So that's the key thing, 4 equal parts. So taking a look, and even here looking at my basic math facts and 36 and 4, I know that 4 times 9 is 36. So I know that there would be 90 degrees if we were to partition that circle into fourths. Here we go with that 90 degrees, bringing us back to something that we learned last week, that 90-degree angle, noticing that when we partition that circle into fourths, we actually are making 4 right angles. Why? Because those rays share that common endpoint that's located here at the vertex. So we talked about 1/2, we now have 1/4. In our last and final, we're going to partition this circle into eighths. A quick, easy way that kind of always helps me when I'm partitioning into eighths. I start with my original fourth, and then I take each of my fourths and I just split those into 2. That way it can create that partition circle into eighths. So now once again, I have my 360 degree circle that I've now partitioned into eighths. So now taking a look, and I can actually look at my partition into fourths to help gauge or gang me when I'm looking to figure out 360 divided by 8. So taking a look, I already know that my rays share this common endpoint. And if this angle is a 90-degree angle, this is letting me know that this eighth, now that they're partitioned into two, I'm simply taking this 90-degree angle and splitting or cutting it in half to form an angle here, which would give us a 45-degree angle. So if you were to go through each eighth piece, you would first be able to identify that right angle. From that right angle, you'll then be able to partition it into that angle of 45 and so forth.